Hi, today we're going to be going back to regressions. You've done regressions before, you've done linear regressions and quadratic regressions. So now that you've learned about exponential equations and log equations and how to solve for a base, we're now going to do 3 other regressions. And these are the last 3 regressions you need to know how to do. The regressions are the same way. You're going to put them in your list. And then the only thing from now on is you have to make sure that you use the right regression equation. They're going to tell you which one to use. So for problem number 1, the breaking strength in Y in tons of steel cable with diameter D in inches is given in the table below. So obviously the bigger the diameter of the cable wire, the more tons it's going to be able to pull. Okay, so the question says to find the exponential regression equation. So now you know which one to use. Also, make sure that you round correctly, and they want you to round to nearest tenth. Okay, so going to our calculator, we are now going to do what we normally do. We're going to put our list in, and the information on the right is the information for the 84. But again, it's the same steps you used to do before. So go to wherever it is your tables are in, input your data. It's going to take off the unnecessary zeros. That's okay. Okay, so just double checking that I did in fact type them in right. Looks good. Now we're going to go ahead and do our regression. So the same way you get to it, get to your menu or your statistics, go to calculation, stat calculations, and then find the one that you want. So we've done number 4, that's the linear regression. We've done number 5, that's the quadratic regression. And then the other 3 that you need to know are further down. Okay, so 0 is exponential. ln, that's actually logarithmic. We're going to use that in a second. Oop, and one more. And then you're going to also need to know power. So the ln regression, the logarithmic, the exponential, and the power are what we're doing today. Okay, so we're going to press the exponential one. That's that one. And again, I'm sorry, my calculator looks different. You're going to make sure that it says X list. You're going to have L1 there. That's where I put my X list. And then where your calculator says Y list, make sure you have wherever you put your Y list. Ours in the 84 was L2. And then we're going to calculate that. Make sure on the 84 that the frequency list is off, like it's blank. Okay, please note, this is what the form of the answer is going to look like. So again, all you have to do is fill in the numbers and keep that form. This guy right here, that means it's a exponent. So that means exponent x. So we have y equals, and that's important. Without the y equals, it's not an equation. We're going to fill in our a, rounding to the nearest tenth. That's going to be 4.8. Then times the b number is 6.8 rounded. And that little caret key means a power, so raised to the power of x. Okay, after you come up with a regression, a lot of times, not always, they'll give you a follow-up question. And again, this is just simply see what information they give you, plug into either x or y, and either evaluate or solve depending on if they give you x or y. So B says, using your equation from part A, determine the breaking strength. Well, if I have to figure out the breaking strength, I go back up here, determine the breaking strength. Breaking strength is the y value. So y, we don't know. To nearest hundredth of a steel cable with a diameter of 2.25. So this means that our x is the diameter. So all we're going to do now is fill in that number right there. and no solving necessary. All the y is already by itself. That's the value we're looking for. So this is easy. Don't make it harder than it is. As long as the variable you're trying to find is by itself, all you got to do now is calculate. Sorry, let's try that again. Okay, and the answer to the nearest hundredth is 358.42. Now we can see if it makes sense. 2.25 would be way over here. So as long as our answer is above 114, I won't know exactly, but it does make sense, at least for what I know. Okay, so now let's go ahead and do the next problem. This is going to be a different type of regression now. So problem 2 says the accompanying table shows the number of new cases reported by the Nassau and Suffolk County Police Crime Stoppers Program for the years 2000 through 2002. All right, it says part BA, if X equals 1 represents the year 2000 and Y represents the number of new cases, find the equation of the best fit using a power regression. And then we have to round to the nearest thousandths. Okay, so because they tell you to switch the year, this is the only time you ever switch the year. Year 2000 is going to be year 1, which means 2001 is one more year later, so that's actually year 2. And 2002 is, 2000 is year 1, 2001 is year 2, and 2002 is year 3. Because that's 2 years later from 2000, and we started with 1. Okay, so same idea. You're going to go back. We're going to go back to our table. We can clear our lists or delete them all out and start over. Okay, so we're going to use 1, 2, 3 instead. All right, that was it. And now again, we're going to go back to our stat calculations and go to our power regression. So just make sure you're using the right one and don't always go to line regressions. So our power regression is that one, PWR, or on the Inspire it actually says power regression. So just make sure you use that one. Okay, again, my calculator looks different. Your X list again will be L1. Your Y list again will be L2. Make sure on the 84 the frequency list is blank. On the Inspires you'll see a 1. Okay, again, this is what your answer is going to look like. All you have to do is fill in the values. So this means A times X is going to be the variable, and this time the B number is going to be the power. Thousandths is our rounding. So 451.431. And that's going to be times X. And then the B, that little caret key means power. The B is going to be the power. So negative 0.243 rounded. Okay, so our follow-up question. Using this equation, find the estimated number of new cases to the nearest whole number for the year 2007. So because we changed the year, we have to actually understand we're not going to type in X as 2007. We have to realize what number year that would represent. And if you look at the pattern, 2007 will be an 8, because if you notice, the number at the end and the number we need is one more higher is the one we need. So it's going to end up being an 8. So that means X is 8. So that means, real easy, I'm going to fill in an 8 right here. And then because this is, everything is already to the one side, I don't need to solve. All I got to do is put this all in my calculator to get my evaluation. Okay, so 451.431. And then times 8 raised to the power of negative 0.243. All right, and to the nearest whole number, that means it's going to be roughly 272 new cases. Okay, and then again, we can just see if our answer makes sense. The number of cases is decreasing, so my answer does seem reasonable, so I can feel good that it's probably right. Okay, one last type now, and that's your logarithmic regressions. Sorry. The data below show the average growth rates of 12 weeping Higgin cherry trees planted in Washington, D.C. At the time of planting, the trees were 1 year old and were all 6 feet in height. Okay, so we don't have to do any changes. We're just going to type that in. And then it says to write the logarithmic regression. So again, just keep in mind what regression we're doing is just the easy part to mess up. All right, so we're going to go back and type in our new data. Okay, 1 to 6, and then the Y column. Okay, so going back to my stats, going to my calculations, I now have to do the logarithmic regression. On the 84, or on the Inspire, it actually says logarithmic. On the 84, you have to know that logarithmic is the ln version. Remember, ln is log, so don't look for log, because some students will mistakenly on the 84s go to logistic because they want to see log, but notice it doesn't have an reg after it. That is not a regression. So we want the ln for these ones on the 84. Okay, so we go ahead and type that in. Again, your X list is your wherever you put your X list, your Y list, and again on the 84s, frequency list should be blank. Compute that. So this is the form of the answer. We're going to have Y equals, okay, rounded to nearest thousandths. So Y equals, the A number is 5.629. Then it has a plus sign. Then the B number goes next, 6.646. And then it has ln of x. Okay, so even on the Inspire, even though it says logarithmic regression, you'll get the ln. Okay, so using this equation, now again, there's usually follow-up questions. Using this equation, predict the height to the nearest 10th of an 8-year-old tree. Okay, so the age is the X column, and that's the Y column. That might help you if you're having trouble trying to determine what variable you have. So 8-year-old tree means that's the age. X is 8. So this is the easy one. Anytime they give you X, it's easy. You fill in and just type in your calculator. Just make sure you show the fill-in for your work. This constitutes the work, and then you can do the rest in your calculator. Okay, now typing it in. Okay, 5.629 plus 6.646. Then you're going to hit the ln key, and then your 8. Okay, so that means the height to the nearest tenth is what they want you to round to, is approximately going to be 19.4. Be careful, this 4 is what you look at. It does not round that 4, don't double round. Okay, and then lastly, using this equation, predict the age of a tree to the nearest tenth whose height is 19.5. So this time the height is 19.5 and our height is our y variable. Anytime they give you the y variable, this will require solving. So y is 19.5. Okay, so I'm going to fill in 19.5 equals, and then the rest. Whoops. With the power and the exponential regressions too, you could have been asked to solve for the x also. So all the stuff you learn this unit is going to come into play when the solving part comes in, if they ask you a question about solving. Okay, so now trying to think about what we would do. My goal is to get to this, so I have to start peeling off the items. So right now I have to peel off the 5 number because you always want to go outside in to solve. Okay, so 19.5 minus over the 5.629, and I get 13.871 equals 6.646 ln of x. Okay, still trying to work to x. Now I have to get rid of this 6 number, and since this is being times, I have to do the opposite inverse operation, which is divide. So I'm going to divide this over. Okay, so that number divided by 6.646, and then you get that awful number, but that's okay. So we get 2.0871200072. You really don't want to round until the very, very end, because every time you round, it could create your answer be a little off. So now you have to understand what did you learn already to help me get to x. And I have a ln here that I have to get rid of, and I don't have an ln there. So if I only have one ln and not the other side, that means to change forms. The base is e. E is the base. This is the exponent. Equals the outcome x. So I now have x all by itself. And again, you learn how to use your calculator. I don't have to retype that all in. I do E to the X button. Then I can go back up there and grab it, and it'll fill it in for me. And that means the age of the tree is, to nearest tenth, is about 8.1 years old.